Hi, yeah, my Michal is Michal Karzynski, and I will be talking to you today about Apache Airflow and writing workflows. So I just have one slide about myself. Don't worry, it's going to be very short. I write code in many languages. I sometimes write a blog, and I work for Intel, and also I do some consulting. So just briefly about me, and now let's get to the talk. So let's talk about workflows. How many of you know what I mean when I say workflow? Okay, there's like 5 people in the room who know. That's pretty good. Because this word is very confusing. It's not clearly defined, and it can mean very many different things to different people. So to narrow things down and to introduce you to the concept if you don't know, let me define it a little bit. So when I'm talking about a workflow today, what I mean is that we have a sequence of tasks that we're going to execute, and that sequence of tasks has to perform some job, some piece of work. Now this can be either started on a schedule, every day, every hour, or it can be triggered by an event happening somewhere. So something is happening, we detect it, and then we start off our workflow. And this is very frequently used when you're doing some data processing and you need to do this periodically, or when some data comes in, or if you just have some piece of work that has to be done at a particular time. So you can use workflows for very many different things. A typical workflow may look like this. You download some data from somewhere, then you send the data to processing on a big cluster somewhere, and you monitor this processing to make sure that it actually completes. And then when it is completed, you can generate some report, send an email telling somebody that the job is done. So this is a typical workflow, but by no means the only one you can imagine. In fact, they get much more complicated very often. But a typical one may look like this. And where are they used? Well, everywhere, really. So you have a whole bunch of different ETL frameworks that do workloads and workflows for people. In data warehousing, you tend to use them. In A/B testing, anomaly detection, and training recommender systems, or anywhere where you have some machine learning system that you need to retrain periodically after some data comes in that you collect. If you're not doing it online, you're doing it probably in a batch job somewhere, and a workflow would be a perfect solution to doing something like that. So those are some examples. The one that's closest to my heart is this one, because that's how we were using Apache Airflow at Intel. What we actually had to solve was the problem of orchestrating a large testing system that was doing a lot of tests. These tests had to run both on schedules and triggered by events. So Airflow turned out to be a good fit for us. So many different applications for workflows exist. And because they do, there are many applications that solve this problem now. A whole number of them arose. These 5 are just the most popular ones that I found, but there are many others. And in fact, most people that use workflows don't even use a workflow manager. They just have a cron job somewhere running something for them. But this problem is so common that a lot of different applications arose to make this easier and give you more insight into what's actually happening in your workflows. So the one I'll be talking about today is this one, Apache Airflow. And this is a really nice application written in Python. It's written entirely in Python. It's open source. It was originally developed at Airbnb, but right now it's gaining very big popularity. It has over 600 different contributors, 5,000 commits, more than 5,000 commits there, and nearly 10,000 stars on GitHub. So it's really popular and used in many places. So obviously Airbnb uses it probably. We use it at Intel, and I've also seen reports of other companies like PayPal and Stripe and others using it. So what does Airflow give us? Why is it useful, and why are people using it? Well, it gives you 3 things. The first one is a framework for writing your workflows. And this framework, like any other programming framework, defines some abstractions, some common classes that you can use to compose your workflows. And I will be talking in this talk mainly about this. But what it also does is it gives you quite a scalable executor, which you can run on many machines, as many as you need, and a scheduler that takes care of making sure that your workflows are started on time, all the tasks are scheduled, if the tasks failed, they're retried, and so on. So that's the scheduler. And the third thing it gives you is a rich web user interface, an application that you can use for monitoring and looking at the logs of the workflows as they run. So before I get into the framework that Airflow provides, I'll show you some screenshots from the web server UI. I was going to show it to you live, but decided that the demo gods are not with me this time, so I just have some screenshots. But anyway, this is what it looks like if you start it. It runs in a browser, so you just open the web page and you see this. And this is the first screen you see. It gives you a lot of information about all the workflows that you have defined. For each one of them, you can turn it on and off at any time if you want to control which ones are running. You see when they're going to be executed, what schedule. This is kind of cron-like syntax for that. And then for every one of them, you see which tasks have recently finished, which ones are running, that would be in this column, which had an error, which ones are scheduled, and so on. And so with just a glance at this screen, you can tell what's going on in your system. So this is quite useful. So these are tasks within a workflow, and these are individual workflows. So the colors indicate what's going on. And from here, you can go into the analytics of the workflow, or the logs of the workflow, or you can trigger a workflow manually here as well. So if you go into an individual workflow, that's what it looks like. It's drawn as a graph on the bottom of the screen, and you can see for a particular workflow, for a particular run, what is the state of the tasks. So these tasks down here, they're colored in two ways. The internal color indicates what type of task this is. So when you're defining your own tasks, you can assign different colors to them to group similar tasks together. And then these bordered outlines, they are indicating what state this particular task is in at a given time. So you can see in real time what's happening inside your system. And then there's another view of a workflow called the tree view that gives you like a history overview of the execution of the previous runs of your workflow, and these green ones are finished. The light green one is currently running. This one is scheduled, and you can click on any of these little squares down there to see the logs of that particular task execution within the context of that particular workflow run. And this is very useful for inspecting any errors, and these logs even get transferred over from the various. If you have multiple executor machines, they will be transferred over to display in the browser when you click it. You don't even have to think which machine that particular log file is on. It will be displayed here. So there's a couple of other views that you have in this UI. This one shows you like a Gantt diagram of the specific tasks, how long they took, when they were started within a certain workflow. So you can see what's executing when and what's starting when. And there are other ways to view like which tasks are taking a long time and when, maybe over history, like in this view. So it's a really nice and friendly user interface for interacting with the workflows that you already have defined. So the web server itself, the Airflow web server component, is actually built on Flask. It uses Flask admin. So it's if you know these tools, you can easily extend it through plugins or even Flask blueprints. So you can actually build on top of that UI your own application, extend the functionality as you need it. The other component, very important for workflow, but one that I won't be speaking very much about, is the worker and the scheduler. And these are also based on open source component. The default configuration is built on Celery. But so with Celery, you get all the benefits of a distributed Celery architecture, where you can have multiple worker nodes working for you. But you can also scale it out with a Mesos cluster or a Dusk cluster. So this can really be configured to your needs. And like I showed you, the scheduler itself has a basic cron syntax, so it's really also very flexible. So let's come to the way you actually code workflows in Airflow. So the Airflow programming framework. It has a number of concepts that you need to keep in mind when you're thinking about workflows, but these are quite simple. They just take a little getting used to. So I will be talking about most of these. The graphs, which are the directed acyclic graphs, the defined workflows, operators, sensors, and cross-com are the key things, and I will be talking about all of these today. So before we go on, I want you to think a little bit of what a workflow actually is and what actually flows in a workflow. A workflow is something that is a series of tasks, like I said, and these tasks make decisions based on the input to the workflow, the trigger that actually started the workflow, and upstream information coming from upstream tasks. So all information in a workflow flows downstream, like in a river. So think of a river for a minute, and imagine what a river behaves like. So a river usually has a source, or it can have multiple sources, multiple tributaries coming together to form a large river. On the other hand, the river usually ends up somewhere. It flows down to the sea, or it may form a delta, like here in St. Petersburg. So you have a river coming to a certain end in one way or another. Then, okay, workflows also have branches. Rivers usually don't, so this is where the analogy breaks down a little bit. But that's because a workflow isn't really like a river, it's more like a graph, and this is the directed acyclic graph idea that's being used by Airflow here. So you define all your workflows as DAGs, as acyclic graphs. And that means that you can actually put some information into your workflow, like you would put some maybe message in a bottle in a river, and it will flow down the river, reaching all the points along the graph, which are downstream of the point where you started. So if you put some information into your graph at point B, it will be available to all the points that are downstream of this graph. And if you put some information in at point D, it will be available to this part of the graph. And in the end, when the branches meet, all the information will be available in the final point. So this way, you can actually decide where information is coming from and where it becomes available by creating graphs of different shapes, and this actually defines the logic of your workflow. So with this concept, the concept of a graph in Airflow, you can define very complex as you need workflows, and the logic of the workflow, how it will behave, is kind of the shape of the graph that you're creating. So what do you build those? How do you build those? Well, it's very simple, really. This is all the code that you would need to write a very simple workflow, except for a few import statements that I left out. You essentially need something, some callable function. This hello world returning function at the top is enough to do something, so let's use that. Then you define a DAG, you define your workflow as a graph. You give it a couple of parameters like a description and a schedule that the graph will use, the workflow will use, and then you can use it as a context manager and assign different tasks to it. You create a task by instantiating an operator and passing it some parameters. And then once you have these two tasks here, you can combine them together using this overloaded bit shift operator into a graph. This arrow just does exactly what you would think. It makes this task downstream of that task, and you can build your graphs like that. And the tasks you define are, like I said, instantiations of an operator class. And an operator in Airflow is the next important concept. It's something that defines a single task for you. So this is actually just a Python class with one method that you have to override, the execute method, and it's going to be run when all the other tasks that are needed, that are upstream of this one, are done. Then this function will get called, and if it fails, it will be automatically retried, restarted. So it should ideally be idempotent, meaning that you don't have unintended consequences if it's run more than once, because it may end up being run more than once. So you can create these operators very easily. This is all the code that you need. You really just need a class that is a superclass of the base operator with one function, the execute function here. I actually added some more code into this example so that you can see how you can parameterize a task by adding some parameters to the init function of an operator. So when you have a parameter like this here, you will be able to use this, you provide a value to this particular instance, this particular task, which will be the instance of that operator in the context of your DAG. So you can reuse the same operator for different things by giving it different parameters. This is very useful for not creating a lot of repeating code, but just reusing the same operator. I'll come back to that. So that were simple operators that perform a single task. There are other types of operators as well. One concept is called sensors. These are operators that are actually going to run for a long time. This is very useful when you're monitoring something happening on another system. If there's a job running for a long time and you need to wait for it to finish, you can create a sensor. And the sensor is also written very simply as a Python class, this time with a method called poke. And this poke function will simply be called repeatedly until the moment it returns true. So this is what a small example looks like. It's a very silly example that just checks the current time, and if the current minute waits until the current minute is divisible by 3. But it gives you the idea of what you need to do. You connect to some system somewhere. This time it's just the system clock. You get some information, and then you evaluate that information. If that information is not what you were waiting for, then you return false. And that means that this method will be called again later, by default 1 minute later. And if the information is what you were expecting, you can finish it. So you can actually return true. You'll notice that I'm also using something called cross-com push here, and I'll get to that in a second. I'm saving this information in cross-com, but that's essentially what you need for a sensor. Just something that either returns false or true, and that way you can have something that is sitting in the middle of your workflow, waiting for something to happen. And this cross-com that I was just pointing out is a very important concept in Airflow, because it allows your tasks to communicate with each other. And the way this works really is that you can store some information in the database, and then in another task query this database and get that information back. It will actually save whatever you put there as a serialized pickled object in the database. So it's best suited for small pieces of data like IDs of objects somewhere, rather than the entire objects themselves. But it's very useful and comes in handy, and it's easy to use. So the way you use it is like I showed before with the minute example. You simply in one task in the context of one operator execute function, you can just call this crosscom push function and save some information, and then downstream in another task you just call this crosscom pull function, giving the ID of the task that saved this information and the key. So just like a key value store for your workflow. And with that, information flowing downstream, down your workflow river, comes from one end to the other. You can actually scan the entire tree of tasks, the upstream of your current task, by using this trick. It just looks for all the upstream relatives of your current task, and then it queries the Crosscom database for a particular ID in all the upstream tasks. And this can be very useful if you don't exactly know which tasks has some information for you, but you're looking for a particular key somewhere upstream of your current task. Now, why is all of this? How does all of this useful in the end? Well, it's useful because it allows you to create reusable operators, reusable components from which you compose your workflows. And this reusability means that you don't have to write a different workflow every time, a different set of tasks every time. You can just build a different workflow, like you're building a structure up from blocks. But in order to achieve this, you need to have operators that are loosely coupled, meaning they have very few necessary parameters. Most parameters are going to be optional, and they will have same default values. So they just need some piece of information to run. The other pieces of information may change how they behave, but they will be able to run in the context of a workflow even without this extra information. So this makes your tasks adaptable, and they adaptable to the situation they're in, the workflow that they're in. So we're coming back to this view of a typical workflow, and now we can translate this simple graph into the Airflow concepts we were talking about. So simple tasks are defined by operators. A longer running monitoring task would be a sensor in Airflow, and they communicate using this Crosscom functionality. So with this, I want to show you a few other things that you can do to achieve different shapes of your graph. So the first thing is the branch operator, used for conditional execution of branches of your graph. So when you have an operator that is followed by a few different branches, you can simply use this branch operator. It looks like this. It's very simple. It's just a function that returns the name of one of the tasks that's downstream. So you have a function, whatever logic you need can be applied in that function, and that will just return whether it's the first or the second branch that will be followed under these circumstances. Another way to achieve conditional execution is when you're in a particular operator, when you're running a particular operator, you can raise a special kind of exception, the Airflow skip exception. And that one will cause the current task to be skipped. It will be marked as skipped. Every other type of exception causes the task to be retried and ultimately to fail if after a couple of retries it doesn't succeed. But if you raise the Airflow skip exception in your task, then that task will be skipped. And skipping a task in an Airflow workflow is like stopping the flow. The information doesn't flow anymore. Downstream tasks normally wouldn't get executed. You would just stop the workflow right there. It's like putting a dam in the river in my river analogy. But you can actually control how whether downstream tasks do get executed or not, even if they're skipped, by using trigger rules, which is an idea in Airflow that you can decide whether the task in your workflow will run only when all of the upstream tasks are successful. That's the default. Every upstream tasks have to succeed in order for the downstream task to get started. But I find that another option, all done, is actually very useful, because then once all the tasks upstream are finished, whether they succeeded or failed, your task will get called, and it can react to the situation it finds by logic that you define. So it can analyze the upstream graph, look for information there, and then generate a report simply telling you what failed and what succeeded, for example. So those are the trigger rules. Another very useful feature of Airflow is the ability to run bash commands as Airflow operators. So you can actually create, if you already have like a set of bash scripts that you would normally use, you can actually turn them into operators, or you can use a bash operator, you can turn them into tasks, and these tasks you can put in your graph. And you can even use Jinja, another open source project, Jinja templates to generate these bash scripts. And you can define Python functions that return some values and use them as macros inside of these bash scripts. I suppose an example is makes things more clear than just these words. So this is what a templated bash command could look. You have a Jinja template that is using some macro. This macro here just returns the execution date of the current workflow, and then if you put some parameters into this bash operator, then you can also use that in your bash script. So you can take an existing bash script, parameterize it very easily, and turn it into an operator, which in turn can be put into your workflow. So that's one other way of adding tasks. Now, Airflow has a number of ways that you can control it. One way is through the web interface, but another one is through this command line interface. So this is very useful for testing and for development, sometimes in production. But essentially, you can inspect your database. You can trigger a DAG, meaning you can start a workflow this way, or you can pause and unpause it, or you can run a particular task in the context of a particular DAG run, which is useful especially for testing. So I often found myself using this last command line, Airflow test, where you can take an instance of a task from your database and run it locally on your machine for debugging. So the command line interface is pretty good. There is another currently experimental interface that is being added to Airflow It's the REST API interface. And it's not fully baked, but this is very useful. Actually, interestingly, this was one of the things that we had to add to Airflow in the form of a plugin when we were working with it. The ability to trigger tasks from another system. This can be very useful, and this is actually what this second command here does. As you can see, there's also a way to control pools, because Airflow also has a whole setup for managing connections with other systems, like external databases or other sources of data, and then you can pool those connections so that you don't overload your database with many queries at the same time. So these pools are you can also control them through this REST API. So a lot of features also in Airflow. I didn't get to all of them, but this experimental REST API is under active development these days. So I mentioned that we needed to extend Airflow, and actually it's very it provides a very good facility to do this through plugins. Now, an Airflow plugin is also very simple, like everything else. I hope you're seeing a pattern here. Everything is simple. You just subclass something called Airflow plugin in a file that you place in a plugins directory in your Airflow installation. So through this type of plugin, you can extend quite a few things in Airflow, and this is what an empty plugin looks like, something that you can start working off of. So you can extend operators, meaning you can add additional operator classes to your Airflow installation just by defining them somewhere and then putting them in a list like this. You can also extend the menu links of the Flask-based web UI application just by adding them to a menu links list here. If you want to add a whole admin view to the Flask application, you can do that as well. You can put a whole Flask blueprint into the application. This is actually how we added the REST API that we needed, by adding a Flask blueprint this way in a plugin. So it's very extensible. The connections that Airflow uses are called hooks. So you can add more hooks, meaning more connections to other systems also here. And you can even make a completely custom executor. For example, the Mesos executor is a different type of executor that runs your tasks, and just put it in the plugin here. So many things, most things that Airflow uses can be either overridden or extended through the use of plugins. So it's a very flexible framework, and I think that's what makes it so popular with so many people. So this is actually the whole set of slides that I have. I have a blog post about Airflow, so if you're interested, you can go to my my blog and find this article there. It will get you started quite quickly with Airflow, and I'm happy to take questions. Thank you.
Thank you for exciting presentation. I'm Luigi contributor, by the way. So I have a question. First one, how Airflow control independency of operation? And next one, does Airflow have configuration files? How can we pass parameters in the run or for configurations, not in the code?
Okay.
Thank you.
Okay, hold on. What the first question you asked was, what was the...
About dependency, one of features what you point in 4th slide or around this is dependency. So I think it's about Airflow control which operations are already executed, which operations must be executed now.
Okay.
So how does Airflow control this?
Okay. The first, let me start with the first question and then go to the second. The dependencies in Airflow are actually another capability for you as a programmer to define when tasks get started. So one way that Airflow knows to start your task is that the tasks upstream have completed and it's now ready to schedule this task. But before it actually schedules this task, it takes a look at these dependencies. And what you can do is actually write a dependency class yourself, and that can check whether everything that's needed for this task is ready, maybe externally to the workflow. So one way we used this was to check our like the systems that we actually needed to execute this task, whether they were up or they were not up. So we could actually, before starting a task, we could check, okay, is that system that we're going to use ready and accepting?
Does Airflow save this information in any storage?
No, it's up to you, because it's a Python function that you get to define. So if you want it, you could save it.
We can define some method for this.
Yes.
It's clear.
Yeah. And the other question you asked was how to store configuration variables.
Yes, some parameters, for example, for operations.
Mm-hmm. So there are actually two things that Airflow has in this scope. One is simply called variables, and that's just something that is a table in the database where you can have a key value pairs of things that you can store. There's a UI for that also in the Airflow web interface, so you can put them in like this. And the second thing that is also quite useful for configuration is another database table that's called connections, and there you define all the connections to the different databases, the different systems that you need to use through hooks that Airflow uses, and that's also then in the UI, and you can put them in the database this way. So that's how it does this. I hope that answers your question.
Cool, it's clear for me now. Thank you.
Okay.
Hello. Could you expand? Oh, sorry, I'm listening myself in Russian, and it's so confusing. Could you expand a little bit more on how to combine Airflow and Dask? Because for me, it's a bit confusing. Like, where does each piece fit into the landscape? And I'm really fond of Dask. I really like it, but I don't know how to combine it with Airflow, or what does Airflow offer in plus that, I mean, of course, all the things that you've described, but how to mix those two?
Well, I'm not going to give you a satisfying answer because I haven't done it myself, but the way Airflow executors work is that they run your Python functions somewhere. So if you have a Dask-based executor, that just means that it's going to be running your code through Dask. And how exactly it works, whether it works well or not, I don't have actually information on that.
Thank you.
Anything else? Again, short time then.
All right. Well,
who gets the T-shirt?
Yes. Well, we have a winner with a question that I could answer.
Okay. Thanks.
Thank you very much.
And